Okay, let's give you guys some more practice. This one's quite tricky. You may have to use a trick that I haven't shown you yet. So somehow work this out. Well, will this diverge or will it converge from two here all the way to infinity? So press pause and have a go. Okay, so to do this, break this up from integrate it from. So we are currently trying to integrate it from 2 to infinity, but break it up as 2 to 20, and then from 20 to infinity. You may ask why 20? Well, if you look at this, because ultimately we want to compare this thing to 1 over the square root of x. So at 20, if you look at the graph, natural log of the natural log of x. So if you look at a graph, natural log of the natural log of x, at 20, this bit here, natural log of the natural log, will always be greater than 1. So going back to here, this bit here, beyond 20, this thing here will be greater than 1. This thing here will be greater than 1. So beyond 20, we can make this this comparison. We can make this comparison here greater or equal to 1. So really, we can make this comparison. And by the way, natural log looks like this. Natural log looks something like this, and it's always climbing. So when you have a natural log of a natural log, then because this is climbing, so natural log is always climbing and climbing and climbing. Then the natural log or the natural log will always climb. So this thing here will always climb. But from 20 onwards, this thing here, just this thing here will be greater than 1. This thing here will be greater than 1. So now we can make this comparison. We can now make this comparison. So hang on, let's go back one step. So we are trying to evaluate this thing here. Well, break this up into one integral plus another integral. Now, this integral here, nothing really breaks down here, and it's going to be a definite answer. So if you look at this bit here, it's a bit like, this is not to scale. At the moment, it's 4, 6, and so on. Let's just imagine this here is 20. Let's just imagine it's 20. Let's just imagine it's 20. So from 2, so that's 2 here. So here you've got a negative area. Who cares if it's a negative area? It's an area. It's a definite area. It's going to be a negative number, a definite number. And then you add this area here, which will be positive. But what you do know is that it's going to be a definite area. It's going to be a finite number. It's definitely going to be a number. So from 2 to 20, it's going to be a definite number. So this bit here is going to be a definite number. The question it boils down to is, will this converge or will it diverge? If this thing here diverge, then the whole thing here will diverge. Because let's just imagine this area here, let's just imagine is 26, let's say. And if this thing here diverge, meaning if the area here gets bigger and bigger and bigger, then the sum of the two will just get bigger and bigger and bigger. If this thing here comes to a definite number, then let's say it comes to, I don't know, let's say 100. Then here you've got a definite plus another definite. So therefore, the whole thing here will be a definite number. So really, it boils down to us trying to evaluate this. It really boils down to us trying to find out if this thing here will converge or if it will diverge. Now, if you make this comparison from 20 onwards, this thing here is going to be greater or equal to, well, it's going to be greater than 1. So we can make this comparison. This thing here would be greater or equal to this thing here. But then, don't forget, you should ingrain this in your head by now. When you see this here, you should know that this thing here will diverge, because 1 over x, from 1 to infinity, this area here will diverge. So here, if the power here is, if this power here is 1, then it's going to look like this. But if it's less than 1, it's going to look something like this. Now this thing here is going to diverge, basically this thing here from hang on, square root of x from 1 to infinity of dx. We've seen many times that this thing here diverged. So therefore, if this thing diverged, this being greater than this, well, if this thing diverged, then this whole thing here would diverge. So going back to here, this is what we want to find out. But then we would break it up into two different integrals. Now we know that this thing here would diverge. Well, if this thing here diverged, then the whole thing here diverged. If this thing here diverged, this thing here must diverge. So the answer is that this thing here would diverge. Okay, it's meaning that this area here will not come to a finite number. Okay.